If we remember, the groups have numbers. We have group number 1, 2, 3, 4, 5, 6, 7, and 8. This tells us how many electrons it has in its outer shell. So group 1 has 1. Group 2, 2, 3, 3, 4, 5, 6, 7, 8. Common sense. Now, what we need to think about is when atoms are at their most stable. They're at their most stable when they have a full outer shell. And with the exception of the first helium, basically, the first period, they have 8 as being the most stable. Think about the noble gases. They're all stable. They all have 8 in their outer shell. So atoms want to try and get to that. Now it's easier for metals at the bottom end, 1, 2 and 3, to lose electrons so they can drop down to the shell below them, okay, than to try and gain 7. So it's easier for atoms in group 1 to lose 1 electron than to gain 7. It's easier for atoms in group 2 to lose 2 than to gain 6, 3 than to gain 5. And it's easy, and it's the same the other way. It's easier for atoms in group 5 to gain 3 electrons. Atoms in group 6 to gain 2. Atoms in group 7 to gain 1. Okay? This is called the valency. The valency. Get a better pen. So it's easier for them to lose those. In the middle, it's the middle. And it's easier for elements 5 and above to gain, to give you 8. So okay, now this is more relevant to ionic bonding, but it's something for covalent as well. If we have 2 chlorine atoms, both of them obviously in group 7, so that means they have 7 electrons in the outer shell. They both need 1. That would mean we have 7 around 1 chlorine. We have 7 around the other. And in the centre there, the 2 ones, the 2 spare electrons, right, they're pulled on by both chlorine nuclei. So what we have is each atom, for a part of its existence, believing that it's got 8 electrons, i.e. chlorine on the left hand side has now got 8, chlorine on the right hand side have now got 8, and so they become stable. And that is where we get the formula Cl2 from. This works with any covalently bonded compound. Okay, covalent bonding occurs in non-metallics. Points to note: covalent bonding, right, occurs in non-metals. Okay. It gives you molecules. So O2 is an oxygen molecule. And has a definition of shared electrons pulled on by positive nuclei. Okay. An easy diagram of this would be to look at hydrogen. And here we have hydrogen nuclei. And here we have the hydrogen electrons for the black one, for the green one. And in that case, we have hydrogen pulling on both of them, on the right, on the left hand side, and the green hydrogen pulling on both on the right hand side. And for part of the time, the two electrons are going around the left hydrogen, and for part of the time, they're going around the right hydrogen. And both hydrogen atoms behave like they have a full shell of 2.